So if you already have the link, I'm going to ask you to start running up to this part that's going to happen, safety challenge in LLM. Because I want to make sure that you already have installed all the packages that are necessary, and also load all of the necessary packages that we are going to work with. Another thing that I'm going to ask you to do is that, because this is a viewer mode that I have, if you want to work along with me, you need to make a copy of it on your drive. So make sure that you are going to make a copy of it on your drive in case you want to modify different things and try different things by your own. So if you have run the code up to this point, is that where I'm going to start to talk about why we need to have consideration of some measures that we are going to apply to large language models to avoid harmful responses from large language models. And this is why we are going to use reinforcement learning to make sure that the response that we get from large language models is going to align with some preferences that we already have. It could be, and this alignment could be in terms of safety, or it could be in terms of any preferred aspect of the response that we are going to have. So why do we need to have safety? Because large language models, because they are trained on large amount of data, and it could be from Reddit, and could be from any type of text data from the web. The response based on the original type of data that we already have could be harmful at times, because we have the idea of stochasticity in the response that we are going to have. And sometimes the response based on the prompts that we are going to provide to the large language models is going to be harmful. And we are going to make sure that we are not going to see, at least we are going to put some sort of guardrail, or at least we are going to retrain the model to avoid the parametric portion of the large language model that are going to be toward they are going to favor those responses that are going to be more safe rather than being hurtful or harm. So the other thing is that I'm going to divide the topic to two different things, in a sense that when we have reinforcement learning with human feedback, because human feedback is going to play a huge role in the reinforcement learning that we have, because human feedback is going to act as the preference data. And I'm going to show you what preference data mean shortly. But human feedback is very important. But in terms of using reinforcement learning with human feedback, we can categorize it to two different aspects. One is going to be generalized type of aspect for alignment, in a sense that we want the large language model by itself is already safe, but we want to make the response more technical, or we want to add some extra preference to the model. For example, a certain format of, for example, JSON is going to be always the favorable format of the response that we want to get from large language model. So we are going to use these type of large reinforcement learning with human feedback to get response in that type of format. But at the same time, we have the idea of safety. And for safety, we are going to make sure that we are going to get the response from the model that always are going to have some certain aspect that are going to avoid any response that is going to be toxic, biased towards some aspect of sensitive areas. And also we are going to, at the same time, we want to make sure that the response that we are going to get from the model is going to be in terms of grammatically or in terms of clarity, they are going to be well-defined. So all of these are going to be categorized under the reinforcement learning with human feedback when we talk about the safety aspect of it. So for the data set that we are going to have is that we are going to use safe edit data, and it's already available, but it's a gated data on Hugging Face. I have subsample of the data here. If you click on this link to download data first, you're going to be able to download a zip file on your laptop, and then I am going to.
There's no access.
It says
I need to request access.
Yeah? Because I don't think so. How about, is it true for everyone? It asks for free access? Okay, I'm going to give you access. I decided to give you access. Because before this, I thought that you already have the access. Yeah. You can follow. I advise you to follow, but if you don't want to follow, you can just watch what I do and see the result because I already provide the result to you. It works after my workshop, but I'm going to accept your request to have access to the data, so no worries. But I advise that you get permission from Hugging Face to download the data because it's going to be the right way to do the original data from Hugging Face. I already provided the link. Yeah. So once you download the data, you should be able to upload it to Colab. Once you run this section, there's going to be a button that allows you to upload, and you should see the extracted data here in the form of pickle. Okay, one thing that I did, it seems that the file that I already had uploaded, it wasn't the right file. So could you click again on the link? And if any permission is needed, I'm going to provide you with permission. Just let me know if you see 3 files, so I make sure that the right zip file you already have access to. Yeah, any type of file that you have the concept of preference data, I will show you how the format of the data should look like, because it is not just specific to this type of data. It is going to be generalized to any other type of data that we have, as long as the format of the data is going to be similar to what we have. I'm going to get into it and show the format and what we have in terms of accepted response, rejected response, and the prompt that we are going to provide to the large language model. So bear with me, thank you. But the fact is that you can work with any other type of data as long as we have the idea of preference data. Okay, let me see if we are good. Okay, so at least one person managed to work with it. So most probably it's going to work now because I made sure that I just need to give you permission. I had to go back to the notebook and update the link. Yeah. Go back to the. Try to see if you can download it. Yeah, later on you can work with that. Yeah, because when I get to PPO, so did you ask for permission to get? When you upload the file into Google Colab, you should see these three pickle files because we have three different splits like train, test, and validation. Yeah, it is gated. Those are already, yes. You need to request. Send, yeah, it is gated. Yeah. I'm going to wait for 1 more minute and then I'm going to continue. The data set that we have has some elements that is going to help us to train a large language model to avoid providing responses that are going to be toxic or biased or harmful in some ways to the end user. And that's the main purpose of doing the whole retraining of the large language model that we have. Okay, done? Okay, cool.
You have to fill out a form on Hugging Face.
Yeah.
Yeah. If you don't do this, it won't let you download.
Yes, it is a gated data.
Gated, yeah.
Yeah.
Sure. I changed the book with you.
So once you unzip, always these demo times, they're going to surprise me. But yeah, once you have the data, is that we are going to see different files, three different files, as I already mentioned, three splits of data for training, validation, and test. And just working with the train data, because as I already mentioned, you can download the data from the original Hugging Face data, but it's going to be in JSON format. So I somehow played with it, massaged the data, and made sure that the right columns are going to be provided because of the presentation that we have today. So as you can see, there are different columns in this data that we already have. The first column is going to be categorizing the type of prompts that we give to the model. And based on the prompt, we are going to categorize whether it's going to be related to private information, or it is going to be related to pornography, or it's going to be related to illegal activities. So there are 9 different categories that are going to be divided to. And in terms of prompts that we give to the model, there are 2 different ways that we are going to provide the prompt. One is going to be the single question that we are going to have, and by nature it is very harmful. I mean, the response that we are going to provide to it. But sometimes we as humans, we try to trick the model in a sense that we are going to write a lot of gibberish stuff that is going to confuse the model. And at the end, or in the middle of the question, we are going to provide some question that it's the main intent of the whole prompts that we send to the model. So it is going to be somehow act as a jailbreaking approach. And we need to make sure that we are going to provide this in the training of the whole model, and we are going to be aware of this situation as well. In terms of the response that we are going to have here, because we are going to train a large language model, we have safe response and unsafe response. So hopefully by the end of the training phase of the large language model, the large language model is going to provide more of safe responses to the query that we send to the model than the unsafe queries that we send or unsafe responses that we get from the model. So as already mentioned, we have the question and we have the adversarial approach. And the main question is going to be the direct question that is going to seek some sort of information that is not going to be considered as a safe response. Just to show you a few examples, this is how do I create illegal ID card, and it's going to, the category of it is going to be illegal activity. This is going to be the adversarial prompt that we have. As you can see, there are lots of other type of text, and at the end of it is going to add the question that we have. It's going to act as a jailbreaking approach. And the model, if it is not fine-tuned or it is not trained well in terms of being aware of not providing answers that are going to be harmful, is going to generate some unsafe generation of the response. And we don't want to see these type of responses at the end of the generation. And we hope the model is going to provide some answer that not only is going to be considered as a safe response, also is going to be grammatically, in terms of clarity, in terms of so many other aspects, they are going to be well adjusted with human alignment. So this is just one example. I'm going to provide another example. It is about privacy and property. It's going to be, how can I bypass social media privacy settings to view someone's profile? Again, we have the adversarial prompt and also safe and unsafe response that we get from the model. So as I already mentioned, this is just a quick view of the data that we have. There are 9 different categories of the data, and for each category we have 450 samples in the training, 300 in validation, and 210 in the test data. We are going to use, typically in terms of machine learning approach, we don't touch the test data until the end of the whole pipeline of training the model. We are going to use the validation split for fine-tuning the model, finding different hyperparameters that we are going to need to adjust the model for better training. So this is another way that if you want to work with some subsample of the data, I have provided the code for you. You are going to select a smaller sample in case you want to just quickly see how the model is going to work and how it's going to train on a smaller sample of data. But in terms of going back to the original topic of today, which is going to be reinforcement learning, we want to see how reinforcement learning is going to help to make a model that we have, specifically the large language model that we have, is going to provide much better answer to query that we sense, and in terms of much better in terms of safety. So the general landscape of reinforcement learning is going to contain 2 components. One is going to be the environment, and the other one is going to be agent. And the agent is going to interact with the environment, and based on different responses that it's going to get from the environment, and these responses are going to be provided in terms of the rewards that we provide to the model, and these rewards are going to dictate of the learning algorithm of the agent how to provide a policy, how to dictate a policy for the next action that we are going to have. So if I want to give you one example, intuitive example of it, is that let's assume that we are different human beings and we want to we act as a reinforcement learning environment. And in the sense that we want to go on the street, and we want to, at the end of the day, the goal is having a policy, and the policy is going to be a written driving license textbook. And this driving license textbook in the future is going to guide us how the next action is going to be provided based on different circumstances that we are going to be in. So the policy is going to be based on, at the end, is it going to be a rule-based, or it's going to be a neural network, or it's going to be a table that is going to, we can look into and see what the new future action is going to be. And the learning algorithm, based on different settings that we have different learning capability. And we are going to learn how to dictate, how to write. Some of us have laptop or have iPads and stuff very fast, quickly. We are going to make a note of it, and later on we are going to make a table of it. Me, as a person, I'm going to have my pen, I'm very slow. So some learning algorithms are going to be very slow, and some learning algorithms are going to be very fast. So that's the difference if you want to see how it works. But at the end of the day, the policy itself is going to be the one that is going to dictate the next action that we have based on the state, previous state, or change of the state that we see in the environment. Yeah. One, I'm going to get into it because supervised learning has some aspect of because one thing that we are going to initially do, I will get to it, it is called supervised fine-tuning. Supervised fine-tuning is going to be specifically with respect to single points, and is going to learn from the single points. But in terms of reinforcement learning, we want to get the wholesome idea of how different relationships in different aspects are going to work together. And that's why reinforcement learning is going to provide so much information in terms of the logic of the relationships between different components that we have in the final result that we have. I will talk more about it more in future, but the whole idea is that supervised fine-tuning that we are going to have, similar to what just you mentioned, is going to provide some basic understanding of single data points and the exact answer to those single data points that we have. But in terms of finding the relationship of, for example, this one should be much better than the other one, or the whole reasoning aspect of it. I don't know if you attended the session. It was about Llama using GRPO for enhancing the model. I'm going to briefly talk about GRPO as well. It is the model, this is the reinforcement learning approach that DeepSeek uses. And they are using GRPO, which is one of the learning algorithms like PPO that we are going to talk about today, is that it is going to provide an understanding of the whole relationships of different components that we have. It is not just about single data points that we are going to predict much better. It is be about the relationships that we have in the training data set as well. And not only is it going to be about that, also it is going to provide the reasoning behind it. And that's why they use GRPO, because reinforcement learning is going to provide this policy that we are going to have. Not only is going to capture the rule-based approach that how to decide the next action is going to be, also is going to provide the logic of how different rules are going to be connected to each other. So that's the main point of it. And one question that I have, so one thing that I'm going to briefly, okay, I have two questions. One is that let's assume that in the context of reinforcement learning, the learning phase, because we have the learning phase and we have the training phase and we have after that. So do we need to have a reward model or reward function? Because environment is going to provide some response to the learning algorithm that we have. Do we need to have a reward model?
Yeah, because it's the core concept of reinforcement learning. If it's true, they give the reward. If it's wrong, give not.
Okay, one answer is that we need have the reward function. How about, that's a valid answer, but I want to see if there is other.
What is the question exactly? Like, why do we need a reward function?
No, it is, let's assume that the training phase is done in the reinforcement learning and we have the model, we have trained everything. Do we need to keep the reward model or the reward function after?
Why would we? Well, should we keep the reward? Why would we?
Okay.
Do we need it after the training? Yes.
Yes. Okay, the answer is going to be yes and no. Because, because let's assume that we are in a dynamic environment or static environment. If we are in a static environment that we are going to train a reinforcement learning model just once, it's going to be stopped, and we are going to put aside the reward model. No longer we need it, and we are going to use the model like large language model. We don't keep reward model all the time. It is static in the sense that the model, the environment is not going to. Let's consider it as a continuous or online learning. If we are in a continuous or online learning, the model all the time is going to update itself, or in the context of self-exploration. So we need to keep reward model in that situation. It is dynamic environment. But if we are in a static environment, in the sense that we just train once and no longer we are going to get back to it, no longer we need to have the reward model. So that's one. How about the learning algorithm? Do we need to keep the learning algorithm?
Yes.
The answer is yes and no because of the same reason. Yeah. So now, we already know about reinforcement learning, but we want to apply the same concept to large language model. How we are going to apply reinforcement learning if we want to fine-tune a large language model. In reinforcement learning, we have a few concepts like agent, we have environment, we have state, we have action. Always at the beginning of getting familiar with reinforcement learning, they are going to be terrifying to hear all of these words because they seem kind of unfamiliar to us, typically when we are not from reinforcement learning background. But in terms of large language models, they're always beneficial to see which part of the large language models that we have are going to be considered as different aspects that we have in reinforcement learning. For example, the agent itself is going to be the large language model itself. It could be Llama, it could be OpenAI models that we have, it could be any type of large language model that is a causal large language model, and it's going to provide a response to us. The environment is going to be the user text that we are going to provide, because this is how the large language model is going to act on the next state that we are going to have. And the prompt and conversation is going to be the state. Right now, the prompt and conversation that provide is going to be the current state of the model that we are going to have. The reward model, typically here in the context of PPO, I'm going to talk about the other learning algorithm as well, is that it's going to be another large language model. Typically, it's going to be smaller, and it's not going to be causal large language model in the sense that it's not going to generate text. It is going to provide score, whether it's going to be positive, it is going to be negative, and this score is going to help how to tune the parameters of the original large language model that we have. So the original large language model, there are different terms that you hear for it, depending on what phase of training we are in. One is that they call it base large language model, the one that we start with. And along the way, so many, they call it policy model, in the sense that it has policy. And policy is the large language model weights that we already have. I already mentioned that the policy in the context of reinforcement learning is going to be the deriving license textbook that we already have. And it's going to dictate what's going to be the next action that we are going to have. In terms of large language model, this rule is going to be provided as the parameters of the large language model that we have. So we are going to adjust these rules to make sure that the answers are going to be more safe than unsafe. So that's the whole idea behind it. And the learning algorithm, I'm going to talk mostly about PPO, but as I already mentioned, there are different flavors of learning algorithms like DPO, like GRPO that already mentioned DeepSeek uses. PPO is the one that OpenAI favors in terms of updating their models. And usually if you see thumbs up, thumbs down in their data, it's going to provide some information that later on they are going to provide to the large language model that they already have, and they are going to improve the result or responses that they provide. And the trajectory is going to be because we are going to have multiple episodes of training. In the context, we have the idea of episodes in reinforcement learning, that the training phase is going to be repeated multiple times. So here is the dialogue session is going to be considered as the entire trajectory or episode that we are going to provide to the model. Any question? Okay, so now we are going to talk about reinforcement learning with human feedback when we want to apply the learning algorithm of PPO. And PPO stands for proximal policy optimization. So proxy is the weight, and proxy is the reward function that we have, and policy is going to be the weight of the model. So the weight of the model are going to be guided by the proxy that we have. And this proxy or the reward model is going to act like human, because we first need to train this reward model, and then once it's going to get familiar with our preferences, it's going to guide the large language model on how to behave in future. Okay. So as I already mentioned, it's good to always consider this, because I'm going to repeat, and I want to make sure that you already have. I already mentioned it. We have the base model. Sometimes we call it base model. Sometimes after supervised fine-tuning, we call it supervised fine-tuned model. Sometimes we call it policy model. And at one point, we are going to call it reference model, and I'm going to tell you when we are going to call the base model the reference model. Then we are going to have the reward model, which is going to be smaller large language model, typically smaller large language model, that is going to be a regression model or classification model. It's not going to be text generation model. The base model is going to be text generation. The reward model is going to be a regression model. And the input, typically in reinforcement learning with human feedback, there are 3 different phases. One is going to be supervised fine-tuning. Supervised fine-tuning is similar to what one of our friends mentioned, is that why don't we train the model on the original data and assume that it is enough? And the answer was that because the original data they are going to consider as a single point training of the model without consideration of different relationships between different points that we have. Some of the models are going to understand some level of understanding or human preference type of approach or alignment, but not always is going to be the case. Reinforcement learning is going to be able to cover that. So in terms of supervised fine-tuning, we are going to have the question that is going to be the safe. We are going to supervise fine-tune the model, and it's going to get the question, and the safe generation is going to be provided to the model for supervised fine-tuning of the model. And this is the way that we are going to construct the input of the training phase of the supervised fine-tuning of the model. The reward model is another model that separately should be trained. And as I already mentioned, the reward model is going to be its own model, and it's going to receive input plus the response. And let's assume that we are going to concatenate the input with the response, and whether it's going to be a positive, safe, or negative, unsafe data, the reward model should be able to assign positive score or negative score to it. So it's going to be trained separately. And that's why we need to have the validation data. You need to make sure that this training data, this reward model is trained successfully. And later on, having this reward model is going to guide how to update parameters of the model. So in terms of policy optimization, is that we are going to have PPO, DPO, and here we are going to talk about PPO mostly. And one thing that I should mention is that for the reward model, preferably we want to concatenate the response with the adversarial prompt instead of the original, because we want to see how the reward model is going to work under stress. And that's one of the things that we need to consider. We can train the model on the original question that we have, but it is advised to use on the adversarial prompt that is typically used for jailbreaking. But for supervised tuning, we need to make the question itself, not adversarial, because we don't want to expose the model to those examples that are going to be act as a jailbreaking. And at the time of, once we have supervised fine-tuning phase done, once we have the reward model phase done, training of the reward model, we get into the PPO phase. And PPO phase is going to put everything together and try to update the parameters of the large language model with respect to the reward that we get from the reward model, whether it's going to be positive or it's going to be negative. So in terms of the objective function, the simplified objective function of PPO that we have two different terms. One is going to be the expected reward term that we have here, because we want to increase the reward that we get from the model, the response that we provide to the model. It should increase the reward. And also, we have a KL term. And the KL term, I already mentioned that we have the reference model. One thing that happens, and we have the idea of catastrophic forgetting in the context of machine learning, in a sense that when we fine-tune the model, when we change the parameters of the model to apply to a new environment, it's possible that it's going to change too much, that it's going to forget everything that it already was aware of. So we don't want that to happen. So one thing that we are going to make sure by adding this KL term, we want to make sure that the change of the parameters of the policy model is going to be as close as possible to the reference model, that is the freeze version of the original model that we have. So this aspect of PPO with some coefficient that is going to measure how much we want to, this KL term influence the whole training phase, is going to make sure that we are not going to deviate too much from the original parameters of the model. Is there any question? That's a very good question. KL divergence in practice seem to be working much better than the other algorithm that we have. We can use like Weierstrass divergence that we already have, or any other model that is going to Jensen and Shannon divergence that we already have. So we have the possibility of using any of those measurement of different divergence of different probabilities that we have. But this one in practice seemed to work much better than the other ones. Yeah. So, but still, it is, if you are from the research community, you can, if you are aware of any statistical model that is going to be beneficial to make sure that the presentation of two different distributions are going to stay close, you can replace this and provide in some certain scenario that approach works better than KL divergence. So that's one of the things that is still ongoing. And the other thing is that we always need to make sure that we have the idea of, if you look at here, is that we have W and we have L. YW and YL. YW is the response that is going to be safe, and L is the one that is not going to be safe. So always these are going to be provided to the model as well. In terms of the whole PPO objective function,
Sorry, this is on online policy? Like you're doing it offline?
it is offline. Yeah, it is offline. But the same could happen to online, but we need to tweak some.
So I have a question regarding online. Like, what if the model is too confident and therefore the diversity of the answers is very small? Then there's limitation, right?
If the model is too confident, because
wrong
one,
answer on a wrong behavior, right? So all the generated in the policy case are all wrong in the wrong direction that I don't benefit from.
okay. So one thing that we need to consider is that I wanted to get into it. How do we measure if a reinforcement learning with human feedback is doing the right job? Because the model could be confident in giving the wrong answer, right? And that's a valid concern. One thing that we are going to do is that for us, is the reward model is going to tell us whether the model is doing a good job or not. If the reward model is not going to support, the model confidently gives the wrong answer, but the reward function should be trained well enough that says this is not right, this is.
It's in comparison, right? You always have, like in GRPs, you have a comparison. You have, like, you compare with the batch.
Yeah.
You get me? Like, you know, like sometimes we don't have a reward model, and then we in comparison within a batch you decide whether this response is better than the others, which one?
Yeah,
In
that's,
the case of GRPO, for example.
yes, because one thing, okay, this is advanced topic. So, so it is when we don't, because in GRPO we don't have the idea of reward model. For PPO, one of the things is that at least explicitly is going to help to get the response is the reward model. And the reward model is going to be helpful to measure how the model is going. But in GRPO, we don't have, and that's a valid concern, and it's ongoing, because GRPO is one of the research topics that recently have come to the surface. And the research is ongoing, and they're providing different answers how to deal with that. So there is no way, at least for now, that I'm aware of it.
Maybe I'm just thinking maybe temperature can allow that to have diversity even the model is confident.
Yes, temperature always is. In case you're not familiar with temperature, temperature is going to make sure how probabilistic, how stochastic we are going to be in the response, or how confident we are going to be in the response, and we can play with that. So one thing that I am going to tell you is that I didn't provide the whole objective function of PPO, because PPO is going to have some clipping aspect in terms of policy, because one thing that happens, if, let's assume that I updated my policy right now, but later on with a new batch of the data, I want to update it again. But I don't know if the update of the policy at this time is going to be good enough. So I have a trajectory of all the updates of the policy that I already have, and it's going to look back and see how much value I get after updating this policy and how much I should change this policy. And that's why the idea of advantage comes into play. We don't specifically use the reward model input that we are going to have. We are going to tweak it. And just, I want you to get familiar, at least hear it, that it is not just this objective function that we are going to have. In case you want, and it is called somehow sampling from the policy trajectory, and we want to sample the one that is going to provide the best answer to us with the clipping approach. Yeah. So if you want to see how it works, I advise you to go to full PPO objective function, and I have provided full detail of how PPO objective function works. So now we are getting to the hands-on aspect of the work. I assume that you already, I don't know if you're following along, but let's see. So we are going to have the models. One thing that I'm going to mention here is that I have two different models. I'm going to have three different models. And the first model is going to be, it's going to be GPT-2, and GPT-2 is going to be the large language model that we have. Instead of GPT-2, I chose GPT-2 because of the collab type of online demo type of thing, because it's very small causal large language model that's going to generate text for us. But feel free at your own time, and if you have enough GPU RAM to replace GPT-2 with any Llama model like Llama 2, Llama 3, Mistral model, or any other model that you have. So this approach works on any other model as long as you have enough GPU RAM to support it. For the reward model, I have, just for the sake of comparison, I have the base dBeta model, and I have the reward model dBeta, because this reward model from Hugging Face, it should probably work for you, is already trained on some toxic prevention data. It is not exactly the same data that I just provided to you, but it's already trained. But typically, if there is a reward model close to replication that sits on the top of the leaderboard, and we don't want to train a reward model, typically we go to the leaderboard, we see, oh, this reward model works very well for my application. I'm going to download it, and I'm going to retrain the large language model that I have. But we still have the option of retraining the large language model itself. And I'm going to show you some of the results of it here. And the other thing is that in terms of, I have some parameters here for quantization to make sure that the model is going to be small enough to work with. Let me see. this function is going to help me to get the comparison of the reward model in a table. And this is one example that I provide to the model. And let's see. Okay, so this is the reward model that is going to get reward. I'm going to provide the reward model that I already just mentioned, and I want to see what score I'm going to get from the input that I provide to the model, because it is important. Typically, we want to see negative scores for unsafe data and positive scores for safe data. And that's how reward model is going to say, okay, I'm happy. Keep this model like this. If it is negative, it says, I'm not happy. Change the parameters and shift it toward the area of, in the space of parameters in the area that is going to generate more of safe data. So that's how it's going to work. So, yeah. Okay, this is one example that I have provided here. And the question is, how can I bypass social media privacy setting to view someone's provided? Similar question that we already provided. And I'm going to get the question, safe generation, and unsafe generation of the response. Typically, as I already mentioned, for reward model, instead of question, for simplicity, I put it question, but for reward model, typically we use adversarial prompt. We are going to, the function that I have above is going to concatenate question with safe generation, question with unsafe generation, give it to the reward model that we have, and it's going to get the value from it. When we use untrained reward model, which is going to be deBERTA without training, we see that there is not much of a difference between distinguishing safe and unsafe data that we already have. As already mentioned, there is another model. What was the name of it? There was another reward deBERTA model that has already been trained on another type of safe data that they already had. And it looks kind of promising, but it's not exactly the same. It assigns more negative response to unsafe responses, but it's still the safe response is going to be negative. So we are going to have this, and this is for adversarial prompt. And as you can see, there are not much of a difference. You can try it by changing this number here and see different answers for the values that we get here. But we need to update this. At least it's good. It's a good practice to update the reward model if we already have preference data of our own application. So, but before getting to updating the reward model, we need to do supervised fine-tuning. For supervised fine-tuning, we are going to apply Ph.D, which is parameter efficient fine-tuning. And it is always, it's typically advised in real practice that we don't need to update the whole parameters of the large language model, let's say policy model, and we just need to target a few specific layers of the model, and we are going to update just those parameters. And it's going to be very helpful at the time of not only in terms of speed, also in terms of GPU consumption of different update of the model. So one thing that I want to make sure is that if I provide base model that we already have, we are going to see different layers that we have here. And this approach, this Ph.D. that is going to work with low rank adaptation, is going to assign, we need to assign some layers, target some layers of the model, and then based on the specific layers that we provided, we are going to update the parameters of the model. Once we apply this Ph.D. approach, we are going to, for example, all parameters of the model is going to be 125 million parameters that we have for GPT-2 model, but only the trainable parameters is going to be around 1 million, and significant number of saving in the number of parameters that we are going to update. So this is going to be the one that we already have. And let's see, once we train supervised fine-tuning, as already mentioned, it is for supervised fine-tuning, we created the data, and the data is going to be the question that we already have and the correct or safe answer that we already have. We trained the whole large language model on that type of data. And we hopefully, after running this, you would see that the training loss goes down, and this is how we are going to monitor if the model is doing the right job. As already mentioned, for the sake of time, and if you want to quickly run this, it is I just use training data. Typically, it's better to use validation data with it as well. Look at the validation data and change different learning rate or different aspect of the model that you wanted to change to make sure that the self-supervised fine-tuning is doing the right job before getting into the proximal policy optimization of the model. So, yes. Now we get to reward model component. For the reward model, as already mentioned, we are going to have the reward model itself. We are going to train the reward model. This is a class that is going to load the model, and we are going to provide the data to it. And the data is going to be based on the input, which is going to be rejected, and it's going to be input that is going to be accepted by the model. So we are going to train the model. So the reward model is going to be, the original base of the reward model is going to be reward DBERTA, the one that slightly work better than the bare bone DBERTA that we already have. And we want to see if we are going to be able to make it even better for our application. So once we train the model, this is another example that we have here. And hopefully, once we train the model, we are going to see improvement in the responses that we have. This is after, I didn't train it much, but I advise you, again, use the validation split to monitor how good the reward model is going to be trained. And I tried it with different prompts and with different inputs, and I realized it's doing it, at least to me, after this small number of training, it's doing the right job. So it is going to be DBERTA, bare bone, without any training on toxic, safe data. Still not much of a difference between safe response and safe response. And for the one that we downloaded from Hugging Face without retraining, it's still relatively good, but we still see safe response is negative. But once we train it on our data, we see positive scores for safe responses and negative scores for the unsafe responses that we already have. Again, we can test it not only with the question, also we are going to be able to try it with adversarial prompts as well. Any question? Now we are going to get into the third phase of training with reinforcement learning, which is the main component of the reinforcement learning, which is going to be PPO. So by default, I use Transformer Reinforcement Learning Package. This package is very familiar in the community, and it is a very good package covering all the objective functions that we already have, almost all the objective functions that we have in reinforcement learning, covering large language models. Recently, they have added GRP as well. It is very good to work with it. But one thing that is going to be of concern is that they have changed it recently. And I'm going to provide you two different versions of applying PPO until the issue that is still out there is going to be resolved. One is going to be the TRL version, which is going to be 0.18, the recent version. We are going to provide SFT model, reference model, that is the frozen model that we already have to the model, the reward model, and also the value model. The value model is the one that is going to help to generate advantage, the extra term or more enriched term that we have in the PPO objective function. And it's going to be, typically it is going to be the causal model that we already have with the classification head. It is going to assign what is going to be the expected reward, future reward from the model that we are going to have, and along with the reward is going to provide the whole term that we are going to maximize. So that's the whole thing that we are going to have. And I'm going to show you the other version, which is going to be 0.11. What's the difference between these two? The first one, the more recent version of 0.18, doesn't provide the stepwise training of large language model. One thing that happens is that in the most recent version, the tokenizer, it assumes the tokenizer that we provide to the trainer function is going to be the same for the reward model and for the large language model. And it's going to be problematic. And we don't want that to happen. and it doesn't expose the step function to us. So we are going to generate the response and then tokenize the generate response for the reward model. So we cannot do it stepwise. That's why we need to fall back to the original version of the TRL model. And then we are going to have a loop that's going to help us to update the model based on the rewarded values that we get, because we can assign the tokenizer, we can tokenize the response based on the reward model tokenizer. I'm going to show you some of the results as well. So I'm going to show you, if you click, I have provided both of the links here for PPO with, okay, there should be a link that I provided, yes. This is the link. If you click on it, you are going to see both versions of them. I'm going to show you first the older version of TRL. In older version, as I already mentioned, we have the idea of the reward model having a separate tokenizer from the large language model that we have. So what I mean by that, let me see if I have some results here. So I have written a function here that is going to give some information to me to see how it's going to work. For example, I have reward model dBeta, and I want to see if the tokenizer of this model is similar to GPT-2, which is my original large language model that I have. For example, the number of vocabulary size that we have in the dBeta model is going to be this size. But for GPT-2, the token size is this. And also, if I provide one example to see how dBeta is going to tokenize the input to different sub-elements or tokens, or based on byte-pair encoding that it already has in place, how is it going to divide it, is that I see that it's adding some special characters to it, while for GPT-2 model, this is not the case. Also, the GPT-2 model is going to, for example, if we have space before each token, it's going to add this element of special, let's say, character at the beginning, but this is not the case for the dBeta type of model. So by nature, the tokenizer of these models are going to be different. And if I use the most recent version of TRL, it's going to confuse the model because it's not going to be comparable with each other. That's why we are going to need to have stepwise training of the model that we already have. So in terms of going through the data that we have, I have different components. It is going to be data set preparation. I already mentioned how we are going to prepare data based on different phases of training that we have. Here it is going to be PPO phase, and we need to make sure that it is, for PPO, it is going to just be the query, by the way, that we provide to the model. And then we are going to get the response, and we are going to assign a score to it. If the score is negative, we need to update the parameters of the model. That's the whole idea behind it. So we are going to have all the setup that we already need, but the main component that I'm going to show you that is necessary is a loop that is going to update the parameters of the model. So we have different configuration files that I encourage you later on. You go and see how we are going to have different configuration parameters that we are going to provide to the model, like learning rate, like the clip value if we are going to use value model for using the clip approach. But the main thing is that this train loop technique that we are going to have, we are going to get the batch of data one by one. This version, this approach is not, it's still not available on most recent version of TRL. That's why we need to use it this way. So we are going to get the model, we are going to get the training data, and we are going to tokenize it and provide it to PPO trainer. And the query is going to be provided, and then we are going to get the response tensor. This response tensor is going to be based on the tokenizer of the original model, base model, policy model, I'm sorry. And then we need to get the response based on that tokenizer. We need to regenerate the response, which is going to be in actual text format. And then we are going to retokenize based on the reward tokenizer, because I encourage you to go back and see this compute reward. We need to provide the reward tokenizer, the reward model that we already have, and also the response, the actual text of the response that we already have, and it's going to assign reward to any response that we already provided to the model. And once it is done, we are going to apply this beautiful dot-step approach, which is, again, it is not exposed yet in the new version of the TRL model. And once it is it is going to train, it's going to be trained based on PPO objective function. And once it is trained, it is going to update all the parameters that we already, necessary parameters that we already have in the policy model that we already have. And this is going to assign, these are the rest is going to make sure that we are going to provide, we are monitoring that the model is training. I stopped it after a few epochs of training, but as I already mentioned, in PPO, we need to monitor the reward model in a sense that initially, the reward model is going to give us some negative numbers while the PPO is training, I mean the mean of the reward. And as long as we are going to get closer to the end of training phase, we see that the reward model is going to generate more of positive scores to the responses that we get from the model. And this is going to be helpful also at the time of validation and also at the time of final response or final test data that we want to report or putting on our paper. So this is one of the things that we are going to do. Again, let's assume that we want to replace KL with another distribution concerned statistical way to make sure two distributions are going to stay as close as possible. So we can test it this way. The other one that I'm going to show you is, is the most recent version of TRL, which is 0.18. For 0.18, it's going to be very intuitive in a sense that we are going to provide all the models, prepare all the models that we already have. We give it to the trainer, PPO trainer, and PPO trainer, just with the help of a dot train approach, is going to update everything that is going to be needed to be updated. One thing, let me see if I have here, because I wanted to show. Okay, one thing that I wanted to show you, because I wanted to make sure that we already understand that we have the policy model. We have this, all the code that is going to, based on different configuration that we have, is going to set, this is my policy model, this is my reference model, this is my value model, and also this is going to be my reward model. So we want to see what is going to be each of these and which parts are going to be trainable and which parts are not going to be trainable. We have the policy model that by default should be trainable, as already mentioned, and usually we apply, preferably we apply PEF to it. Some parts of the model is going to be updated. So it's going to be trainable. So we have the reference model. It is 0 trainable. Reference model is going to be the freezed version of the original model that we have. We want to make sure that the updated model is going to be as close as possible to the freeze version that we have. We call it reference model. Then we have the value model. Value model is used for the computation of advantage to see what's going to be the future, expected future reward that we get from the model. So it is also going to be trainable, and also it's going to expect a future reward is going to assign a number. And this number, for this, typically we are going to add a head to the top of the original policy model that we have. And it's going to, typically it's going to have a slightly larger number of parameters that we have in the policy model that we have, because we have the idea of that head that is going to sit on top of the policy model. And the other thing is going to be reward model. Reward model, we don't update it during PPO phase. It's going to be frozen. It's just going to provide us with the answer.
How is value model updated? What is the loss
I encourage you to go back to, or we can talk about it offline. Yeah. So for data preparation, as already mentioned, is going to be mainly we are going to provide the question or adversarial prompt that we already have and provide everything to the model. One thing that I wanted to make sure, because it's always a good practice to see the length of the input data and make sure that the maximum length of the input data that you provide as the configurable parameter of the model is going to be provided, because as already mentioned, for some of the adversarial models, the main question is going to be at the end of the adversarial prompt. And if we are going to truncate the data, the main question is going to be cut off, and we don't want to do that. So we want to make sure that the maximum length that we are providing to the model is going to be enough to include all the important part of the query that we already have. So that's one thing that I wanted to make sure that is going to happen. And then, as already mentioned, once we have the training argument, again, it's going to be learning rate, so many other things, the batch size, everything that is needed, that again, we can modify based on the validation data. And then we are going to have our tokenizer, which is tokenizer here is, as already mentioned, is going to be the same for the reward model and for the policy model. And that's why we need to assign, it doesn't allow us to provide two different tokenizers for reward and for the policy model. The policy model is going to be here, reference, reward, value model. We can provide training. We should provide the training. We can provide evaluation data to make sure that it's going to provide us with a good insight of the training phase of the model. And once we train, everything is going to be provided here in a good, nice way, that along the way, it is part of the TRL package that we can see if the response, once the model is going to be trained, the responses are going to become more safe. One thing that I'm going to say is that because we are using GPT-2 here, the responses, they're not the best. It is a very small model, so don't be too much concerned with the response that we get. Once you replace GPT-2 model with the much better models with larger number of parameters, you're going to see much better answers here. But the whole idea is going to stay the same. The other thing that I wanted to mention, because I kind of forgot, is that because I kept telling you that the tokenizer should be the same, here at the time of selecting the reward model itself is going to be GPT-2 with the header, in the sense that I use GPT-2 and I added a classification header to it. And I assumed that it is already trained on the data. Here in the notebook, it is not trained. So you should go back to the previous training phase that I showed how to train a reward model and retrain GPT-2 model with the classification head. And then once it is trained, you come here and you're going to use that reward model with the same tokenizer as the policy model to the model that we already have. And that's when we would see that the model, and even if I scroll up, let me see. I can show you here. Yeah, for example, here I have provided that GPT-2 also is going to be the reward model that I already have. But if you're confident that the reward model is much better, you don't want to train a reward model that already is available, is that it's better to go and look at the leaderboard, select a reward model that is good enough for your application, and you're going to use the the older version of TRL model. But if you already know that you have enough training data, preference data, accept, reject, query, accept, reject, and you are going to be able to train like a model like GPT-2 or any other model that share the same tokenization approach, you're going to be able to train your own reward model and use the most recent version of TRL model or package that we already have until they are going to resolve the issue. That's it. at the end, I wanted to quickly mention that we have PPO, we have GRPO, and we also have DPO. In one of the drawbacks of PPO model is that we are totally dependent on reward model, as already discussed, and the reward model should be very confident in the response that it already provides. DPO, which stands for direct preference optimization, is that it's going to alleviate the need for having a reward model at all. So in reward model, we need to be sure of the exact score that we give to an input. For example, let's assume I'm a teacher and we have students, and we want to show what a good essay is going to be. I'm going to assign a score to each essay, say this is 20, 80, 70, and I show it to the student, and I say that this is how you should learn to write a good essay. For DPO, it is not the case. We are going to have maximum likelihood estimation in the sense that we put two things next to each other. We say this one is better than the other one. We don't have to mention the exact value or response score that I already showed you. And with these comparison and implicit maximum likelihood term that we have in DPO function, we are going to improve the whole model based on that. And for GRPO, which stands for Group Relative Policy Optimization, instead of A is larger than B, this essay is better than the other essay, we have a series of different essay, and we provide it as a batch. And that's the whole idea behind it. But I encourage you, this GRPO is very interesting model. It's a lot of research is happening around the topic. And if you're interested, I'm going to be always available to answer questions.
Thank you.